In this lesson I will try to explain how variables and properties work in CMake. The command message can be used to print values stored in variables. In this first sample we will try to print information from a variable that hasn't received any value yet. As you can see, the first message printed my first variable, and the second also printed my first variable, and the third didn't print anything. And the first thing about CMake and variables that you have to know is that the variables always are strings. In CMake, the first two lines here, they are equal. Even if my first variable there isn't enclosed in quotes, it is treated as a string. And here, where we have quotes, it is also treated as a string. But the third line, that has curly brackets and a dollar sign, there the output was, there wasn't any output here. And that was because when we enclose the variable in curly brackets, the variable value is expanded, and because variable wasn't set, it hasn't got any value, and that was the reason why this line is empty. And we tried to run this and see what's happened. These are the same as before, and then we printed that with this line. That is a comment. Here is a new command. It is called set, and that is used to set the value for a variable. Now when we printed this here, that was the same as this one, because this is just a string. This is also a string here, but here now we have a new value here, because these curly brackets has expanded the variable, and when it expands we got the value in the variable. So here we have, now I have a value that was set here. If we check the tutorial, and we can here, variables and strings, select that and expand. Here is a description about text, and what does it say here? Variables in CMake is always a string. All variables are strings and can be modified with a string command. In CMake there is a command called string, and it can do a lot. I will not go into that now, but just to show that here we have this append, concat, join to lower to upper. To get the value in the variable, you need to expand it, and here is how you do it. If you have used templates in C++, it's a bit like that. Here's how we set it with the set. You can set a new value and expand the old one. When this is expanded, you get this value. If we didn't have these curly brackets here, we would have set that value to my variable. You can't do this, as you see here. Set my other variable to my variable, because then my other variables will get this. CMake can also handle lists that are also a string. So how does CMake know if a string is a list? Lists are strings with semicolons. Each part in the list is the text that exists between each semicolon. So, how can we iterate a list? This loop will iterate and take out each item in the list. There is the list. And here, the second part. List is just a string with semicolons. Items in list are text between semicolons. This list command has a lot of operations that you can do on the list. You can check it. Here you have a lot of sublist, join, get, length, find, etc. There is also a sample here. Simple uses these commands. So if we add a semicolon here, now there was 4 items in the list that was calculated from that command and printed here. If I add a semicolon, it should be 5 items. There we have a 5, but we don't see that value here, and that is because that value is between those two semicolons, and that value is empty, and that is the reason why it isn't any line for it. If we can do like 3.5, and there we got. And what happens if we want a semicolon in an item in the list? If we want that, we do like this. Escape it. Now we should have 4 items again. And there we have the 4. Why didn't the message print the semicolon here? If we want it to print the semicolon, we need to do it like this. That should be taken as a literal string. Now it printed the semicolon. And why is that? That is because if we don't have the expansion of the variable in string, it sees it like this. And if we print that in a message, it will remove the semicolon and print the 4. But if we have that one, it will print semicolon and the 4. And that is also the reason that we didn't got a semicolon on the first run. Properties. What is it, and what is the difference between properties and variables in CMake? It is easier if you understand how language uses them, and in this case how the language in CMake handle properties and variables. I have written some about it in this tutorial. Variable or property, what's the difference? How do programming languages handle variables? Variables in programming languages can be divided into 2 groups, stack-based or object-based. Stack-based variables are stored in memory that each function reserves, memory found on stack. The reserved area on stack grows and shrinks all the time when functions are called. When a new function is entered, that function reserves memory for variables on top of the stack. Leaving function will destroy the area and variables are wiped. Object-based variables are stored in the memory area that is reserved for the object. Object-based variables are destroyed when the object is destroyed. They are usually destroyed by some type of operation or command. These type of object variables are sometimes called member variables. If you understand this, how variables are handled by the computer, it makes it a lot easier to learn new programming languages. And the CMake language, that is a script language, it works like this too, but script languages do not handle the stack as languages that are compiled for the processor. When a function is entered in a script language, the stack is usually one object, and that object knows about its caller's stack. It works like a tree where variable branches grow and shrink. Each branch knows about its parent, and it has leaves that are variables. You can think of that when you enter a function in a script language, it creates list of some sort, and that list has items, and each item is a variable. That list knows about the parent, and the parent is the caller function for. So why do script languages do like this? The startup time for running script languages can't be too long. There's a limited amount of time when it comes to analyzing the code and optimize it. If you run a script, you should be just able to run it immediately. And that's the reason why script languages can't be as optimized as other type of languages that like C++ or C or Java or some other language that are compiled. If we apply this logic about how variables are stored in CMake scripting, we can see what happens. In CMake there is an object called global, and that object has properties. One property there is called CMake CXX known features. And if we try to message that property, we can see what happens. So if we run this, as we see here, no value. Message wasn't able to reach this property. And why is that? This property belongs or is stored in an object that CMake handles. And as I said, that object is called global. And message doesn't know about the global. The message works on variables stored on the stack, or as the stack is handled in this script language. Exactly how, you have to check the implementation, but usually this stack is a form of a list. To get this CMake CXX known features to print it, we have to get it from the object and then save it in a variable, and then use meshes to print that variable. So if we try to do that, we can see if we can get the value. look here. So what did we do here? There is a command called getProperty variable that gets the property value and the type of object. Here it is global, and the property called CMake CX known features. So to get a property you have to first access the object, and when you have the object you can get the property from that object. And when you have got the property you can assign it to a variable. Now it is on the stack, so message is now able to access this variable. Variables are similar to global or local variables, properties or object members. Creating an executable, and here we call it application name. That is similar to say that we have created a target object and called it application name. If we compare this with C++ and we create a target object there, we could see how that would look like. Here we defined a struct called target, and it has a member called name, like that. And here we create an object of the target called application name, like that, when we did it in add executable. And here we assign a value to that name. That is also done in add executable. CMake has a few different objects of this type, and in CMake they are called scope. Variables are also called scope. Maybe not that good name if you are a C++ programmer and use CMake, because then you think in another way that non-programmers do. If we check here, here we have different scope. Global is one type, if we compare, it's one type of this object. And directory, target, source, or you can with get property also access variables, but then you have to tell CMake that you are searching for variables instead of some property in a object. Scopes or objects in CMake are used to set up builds. Each scope manages one area in that process. Variables, on the other hand, are used to add some flexibility in this process. CMake has many standardized variables and properties. And why so many? You can see here CMake variables. There are a lot. Properties for different objects or target tests. CMake is a scripting language to configure applications that compile code. This type of applications has many settings. And as you know, if you are a C++ developer, configuring applications that compile is not that easy. In addition, if you compile for different operating systems with code that is dependent on other components, code that is written by others, etc., that is hard. So, although CMake can be perceived as difficult and unnecessary at start, it quickly becomes a great help as soon as your application grows.